Hey guys, so we're going to continue today with our discussion of reaction stoichiometry. Last video we looked at how to convert from grams of one substance to grams of a different substance. So if, for example, I gave you a reaction and I gave you a certain number of grams of one reactant, you could tell me how many grams of product would be produced. Today we need to consider, though, what about the more realistic situation where you have two different reactants, and you have different amounts of each reactant. Then how much product will I produce? So in that situation, we have to think about which of the reactants will we run out of first. So in all the examples thus far, we have said one of the reactants is in excess. So we stated that we had enough of that. We didn't worry about it. Well, now we need to worry about it. We'll have to determine which of the reactants is in excess and which is not in excess. So the one that is not in excess we'll call the limiting reactant. That's the one that limits how much product we can make. So let's think about an analogy for a second. Think about if you're trying to build cars. So let's say I'm trying to build a car, and to make the car, I need one engine and 4 tires. So let's say, for example, I have 2 engines and 7 tires. So if you have 2 engines and 7 tires, you can only produce one complete car because the number of tires limits the number of cars you can produce. So if the number of tires limit the number of cars you can produce, tires is the limiting reactant because we run out of tires. But we're going to have engines left over. So the engines are in excess. So that would be the excess reactant. That is the one that we have some left over of. And I'll go ahead and let you know the words reactants and reagents are used interchangeably here. So here's just a simple example. It shows a combustion reaction that might occur in an engine. So if we have amounts that perfectly match up and perfectly react with each other, that's what we're trying for. If we run out of octane first, we won't be able to run, the engine will stall. And if we run out of oxygen, then we'll get dirty exhaust and we'll be built up in the engine. We'll come back to the example later. First, let's kind of dive into what we really mean by limiting and excess reactants. So the limiting reactant is the reactant that is consumed first. It's the one that we run out of, and therefore it limits the amount of product that can be formed. Because as soon as we run out of one of the reactants, we can't produce any more product. We're done with that reaction and we cannot go any further. However, the excess reactant is the reactant that does not run out during the process of the reaction. So if it does not run out, there's going to be some left over. So when we finish the reaction, there will always be some of the excess reactant left over. So in a lab situation, this would be wasted reactant because it cannot be used to produce the product. So back to the car analogy, you would have 3 tires left over, 3 tires in excess that we can't really use for anything, they're just there. Okay, so what we'll do in this video is we'll kind of just talk through the steps in words for how to find the excess and limiting reactant. Then we'll go back in following videos and actually do calculations to look at that. Okay? But today, in words, the first step, as always, is to balance a chemical equation. Okay, so we get an equation, then we balance it. Then I figure out all my given quantities. So what is the question telling me? Okay, hopefully, in this situation, it gives you the mass of both reactants. So if the reactants are A and B, we'll have the mass of A and the mass of B. Okay? So then what we'll do is we'll pick one of the products. And it doesn't matter which. If there are multiple products, you should choose one. But it doesn't matter. So solve for one of the products based on all the quantities. So if we have A and B, and they produce C, for example, so C is my product, I figure out how much product I can make based on A. Then I also go back and figure out how much product I can make based on B. So think about the car example. If I have 2 engines, I can make 2 cars. But if I only have 7 tires, I can just make 1 car. So we solve for the number of cars separately, based on the number of engines, then based on the number of tires, and we get two separate answers. Then we can compare those two answers. So the next step is to cross out the larger amount of the two products produced. So in the car example, we have two cars produced based on engines, one car produced based on tires. So we cross out the number 2 because we cannot produce two cars because we've run out of tires. So we always cross out the larger of the two quantities. So the smaller of the two numbers is the one we look at, okay? The smaller amount is the theoretical yield. So in theory, that's how much product we can yield. So at that point, we can go ahead and label one car is my theoretical yield. Based on my theory, my calculations, I can produce one car. Okay, so then we label the limiting reactant. So the reactant that produced the theoretical yield, that produced the smallest amount of product, is my limiting reactant. So in the car situation, the limiting reactant is the tires. Okay? So the limiting reactant is the one you run out of. So the excess reactant is the other reactant. So the excess reactant would be the number of engines. So engine is my excess reactant. Okay? So the excess reactant would be the reactant that produces the larger of the two amounts of product that we cross out. Okay? So I said earlier that it didn't matter which of the products you chose for. We just had to choose a random product to solve for it to do this. While that is also true, it's best to use some common sense here. So if you have two products, like product C and product D, for example, you could choose either product C or product D. But it's probably best to go ahead and read through the question first. And if, let's say, part C of the question asks you about a specific product, it's probably best to go ahead and deal with that one first, because you know you're going to have to come back to it later, so you might as well go ahead and deal with that first. So that is the basic steps in words for how to determine the limiting and excess reactants. Basically, just use both reactants to figure out how much product you can make. The one that allows you to make the least amount of product is the one that's going to limit your process. Therefore, that's your limiting reactant. The other is your excess. And also how to find your theoretical yield. So we can elaborate further on yields in general. So the theoretical yield is the maximum amount of product that can be produced based on 100% efficiency. That means that every single atom or molecule in the reaction does what it's supposed to do and reacts. So based on our calculations, this is theoretically how much product that I can produce. But theoretical yield never happens. We cannot force every single molecule to do what it's supposed to. They're not always going to produce the desired product. So we also have the actual yield. So the actual yield is when we go to lab and we do some chemistry, how much product we actually make. And actual yield is typically less than the theoretical yield. It never quite does what it's supposed to do. Then from the actual yield and theoretical yield, we can find the percent yield. The actual yield divided by theoretical yield times 100 in a lab setting. There are a lot of situations where percent yield might be calculated to be over 100%. So if we have a percent yield over 100%, that probably tells us the actual yield is a little bit off somehow. We probably have some contamination in our product. Typically, the source of error would be water being present in our product. So this is a very common calculation that you'll see in labs. You'll have the theoretical yield from the calculations, the actual yield from the lab setting, then we want to find the percent yield, so how efficient our reaction was, how efficient our process was. So that's the basics, the theory behind limiting reactant, excess reactant, and percent yield. So I'll stop this video here today, then I'll come back in the next video, we'll go through the calculations, what the math actually looks like.